Ladies and gentlemen, welcome to the video. Alright, today, big problem we're having on my 3D printer right here. Where is it? This guy, the tensioner for, hold on, focus. Alright, the tensioner for the extruder, I think that's what that's called, is broken, as you can see right here. Right where my fingers are. The decided to break on me, and I've tried to glue it and super glue it and JB weld it to no anvil. So I figure instead of just spending the $5 to buy another one, why don't we spend 4 hours making one on the very expensive CNC? So that's what we're gonna do. Alright, on to the next scene. I guess I should probably explain to people who are not familiar what this piece actually does in context, if you will. So you got your filament, it's right here, and what it does is it'll travel through this little guide hole, and out through this little front hole, and there's a tiny little bearing that sits right where that broken insert is. On top of that, a bolt holds it in, and the filament will ride in that bearing on its shoulder against this brass wheel, and it'll get fed into the, I guess that's the extruder. It'll get fed into the feed tube down to the hot end, and that's how you get hot plastic. If you don't have good tension on this, you have feed problems, and I was having feed problems, so I'm guessing that's probably the a contributor to that. So really the steps we're going to take here is I'm going to make sure we have a piece of aluminum that fits this, and I guarantee you we do, so that's step one out of the way. Then probably the longest part is we're actually going to have to model it up as accurately as possible. Obviously the most critical things are the bolt here that gets threaded onto there, then this part. Now these are metric bolts. So what I'm going to have to do, I don't have any metric taps in the machine, so I'm just going to hand tap it. So we're going to find the drill that's close enough that size, and then we'll just hand tap it. It'll be super easy. And then this nub, which is like the spring retainer. The spring goes on here. And yeah, so it should be fun. Should be a good time. Alright, so let's go ahead and start modeling this up. So what I'm going to do is we're going to take a picture of the part as square as possible. The nice thing is because it's so tiny, it's easy to get square on a phone. But if you have a really big part, it's kind of a pain to get it all square. So now what we're going to do is I'm just going to send it to my Dropbox, and then I'm going to bring it into Fusion, and then we'll go over what we do with it. Okay, so welcome to Fusion 360. So like I said, we're going to be doing this part. So the first thing I want to do is new component. We're going to call this thing Ender3 tensioner. I don't know how to spell tensioner. Then what you're going to want to do is save your project, and we're going to say 3D print because that's where it goes, or kind of, not really. Cool, so the first thing you want to do is we're going to start a sketch. Make sure you're actually selected on the thing you want to start sketching. We're going to do a top sketch like so, and this is where I'm going to get some measurements, so give me 1 second. Canvas, insert from computer, here's the second one, pick on that face. That looks a little bit better. I'm not sure why they're so grainy. Oh, there you go, that's why. Canvas opacity. Alright, let's pick, let's do 75. That's not 75. Cool. So, in Fusion, what you want to do is, because if you measure this right now, and then, well, if you had points to measure, this image is completely off. So what we're going to do is you can come down on the canvas, right click, and then you can do calibrate. And the cool thing is, what you want to do is measure the farthest points you can on your part. So I'm going to measure the outside. And what we get is in inches, basically 2.2. I don't know if you guys can see that. 2.204. This is all in inches because that's what I'm used to. So I'm going to pick the points that I just measured. So it's this to this, and I say 2.204, and that'll calibrate your image. Perfect. Now what I'm going to do is on this, we're going to basically create a sketch on top of it, and I'm going to draw a line that's straight. Cool. And I think I should be able to rotate the canvas. Edit canvas. Okay, yep, edit canvas. And then what I'm going to do is move it to our line and rotate it so it works. Looks like 0.8 it is. So that's now rotated square with our line, so we'll go back into our sketch. And then I'm just going to start sketching out this actual we're going to measure these two heights. There's the first one I'm talking about, and then we're going to measure the second big part. So for the first one, what we got is basically an eighth, so 0.125 or 0.12. That's what I got on that. And then what we're going to do is do this part, which is 4145. Cool. So you can kind of tell. Oh, you know what I need to do? See this? The nub is 3D'd, and it's not like that in person. It's only halfway up. So what we'll do is go back into our sketch. So let's see. Let's do, instead of picking these dimensions, what we'll do is we'll actually tell it what the diameter of this is. 1955. And then I'm going to measure and see 1624, 1095. So that's pretty close. It's 9th thou. So that's not too bad. I'm pretty happy with that. Okay, boys, I've worked very hard. It's taking me multiple minutes to get this down, and it's not really there yet. We'll have to handle the drilling tomorrow, but I'll just put that in a separate video. So we're going to do a adaptive, which the second I start... Oh, here you go. So you do adaptive, then we're going to do a parallel to clean up the top. And then contour around the thing, contour around that thing, contour over that thing. Parallel these things with a ball end mill. Attempt to parallel this with a flat end mill to get as close to that wall as possible. But for some weird reason, it does not want me to like cut up against the wall. So if we simulate it, and then I go like this. So if you look at it in the end, there is still this fat fillet here, and the part does not have that whatsoever. So I don't understand why this parallel is not cutting up against the wall. And I've messed with it for probably 20 minutes, and I'm kind of tired of messing with it. So I'm just gonna send it in there, and we'll see what it looks like. Like it's cut like this. Okay, check it out. We got our stock loaded. I'll probe it in G54, and then we'll get it cutting. Okay, turn off high-speed machining because I'm poor. Let's see what we got. Very cool. Definitely, this turned out really nice. Good blend on there. Oh, there's tooling marks on the side. I wonder if that's why it shows it weird in the simulation. Cool. Very cool. Oh wow, they're like sisters. Width is obviously very good. The width dimension's pretty easy. That's pretty close. Definitely wider down on this part. Focus. Definitely wider down on this bottom part for sure. But other than that, hole looks like it's in the right place. You're not gonna be able to see, but it lines it pretty good. So I need to find the right drills for this tomorrow. But yeah, that's pretty exciting, I must say. So cool. Okay, I know this video is pretty long, but there's some pretty good info in here on actually making parts that are broken and then copying them. So I'm gonna start doing the rest of it tomorrow, but I'm gonna try to upload this one tonight. And yeah, so if you're looking to see more of this kind of stuff, please subscribe. I'm trying to hit 100 subscribers by the end of the year. Totally a doable goal, but yeah, I got some cool stuff coming down the pipeline. So yeah, thanks for watching.